Doctor, the first thing you say, you need know how much this distance, we change the distance, okay? And the location of this, okay?
Okay.
The location, the main thing, to distributed the flow. And how much the D, how much the diode, how much the, you see my share.
I'm seeing.
Okay, you see, but doctor, we make a lot of design. We have 3 design to optimization.
Okay.
Okay, doctor, this is the another thing here. This design, you say we have this distance with this D, with this D small. You check it, this D small.
Yeah.
And we have three channel. You say you must say what is the D out of DI, like ratio, change, and delta pressure for forward and backward. Okay, doctor?
The pressure for forward and backward is the objective, is the goal, is not a parameter to investigate. Okay? When we are changing the diameter of outlet and inlet, we have to investigate
in the reverse flow, doctor.
The delta P.
Well, in the reverse flow, we have a problem, doctor. You see the pressure? This is for velocity. This is the contour for a pressure. The contour of a pressure, you see here is very, very high pressure. Very. But when come, the pressure be little because no flow. This is we have.
This is correct. It doesn't have any problem.
But the problem here in the pressure outlet is like to be 0. But what is the solution for this? Because when we make delta P here, it's be little because.
What solution? We should at first we have to define the problem. Then we look for the solution. Okay. What is the problem? This figure, this contour doesn't have any problem.
Doctor, for delta pressure, how much for the delta pressure for this contour?
The delta pressure, you can check the difference between the pressure in the inlet from the left side and the outlet from the right side.
The inlet you see is here. You see this number, doctor? Okay. I make it how much? 2.33. Okay, doctor?
I can see it, but I can check it from my file. Okay, let me check it.
Check it, doctor. And I check it from result I show you now.
So the number is 23.
23, okay. The problem here.
23.
For the reverse pressure,
23 Pascal. You see, 23 Pascal is very small. It's not big at all. It's not big number.
Yes.
23 Pascal, not 23 kilopascal. For now, the diodicity is low. It's not high. But we're looking for high diodicities.
But for forward, doctor, you see, this is for forward.
Yeah, for forward, I'm seeing the maximum pressure is about 98, and the outlet pressure is about 0. It's about 98 Pascal difference. It's good. The ratio for now is about 4. The diodicity number is about
check, doctor.
4.
This is for forward.
This is 93.
Yes.
Yeah. For forward, the difference is 93. For backward, the difference is 23. So the ratio between forward to the backward is 93 divided by 23. Is about 4. 4.5.
For software, how to use this? I check you now. I open the software, doctor. I see where is the problem.
So everything is okay. As I
doctor, I read we have a new valve, doctor. This is a new geometry where the ratio of the diodicity 4 or 3 more to 4 or go out. This is very beautiful because we use one stage.
Yeah, I see. That's beautiful. But the point that I'm making is that we have to investigate logically and academically. Okay.
Okay.
When we are going to investigate a parameter academically, we have to have some parameters, we have to have some objectives, we have to have some constraints, because the day that you are going to defend your thesis, every referee, every reviewer who is sitting there will ask you these parameters, these questions. You have
Yes,
to be able
inshallah.
to answer them.
We explain.
Okay.
Doctor, for this we have 3 design, not 1 design. You see, I see the third design more. I think.
Yeah, I check all designs. Yeah.
You see, doctor?
Which one is the best? Here we should choose the best design with the best periodicity number, and then investigate the optimization parameters just for the best design.
Can you check this, doctor? You see, we have 3 case study for 1. This is for beginning. After this, we say this dimension. Not go to analysis a lot of things, because we need some professor, a professional to make flow equation, to make flow for this channel. How much the channel? How much the
we
come?
are not concerned about flow equation.
How to do this, doctor? You say, Ibrahim. If you say to me, we have
easily with the software.
Yes.
Yeah, I told you that I will teach you in the software. We can just assign some parameters and just do the run in the software. Don't worry about the equations. You should not get involved in the fluid equation and change the optimization yourself. No.
You
it's
see,
not like that.
I bring a lot of things. It is like to work for 30 years, for 40 in the future to work. You see this tip, doctor? You see this tip in the main? This is from, we have make loop to make reverse flow. This everything. And all part, I think, for it to improve the flow. Not now I need you have very good خبرات, experience. We say what is the we can change to make what is the beautiful. I think you see this third design, this is more beautiful.
Yeah.
Because here is close with no tip is very, very good. You see what is the beautiful? The second or third for experience. For now you can see, doctor, you can see this is what is the design we have the high periodicity.
We should check here. I told you we should check the periodicity for each geometry. I will check it right now. For the last geometry.
You see, doctor, this? You see, we have very delta P is big, and everything is smoothly. It's come to this region. It's be like delta P pressure be 0. It's come.
Yeah, the difference of pressure is about what? 150 or what? It is.
You can't check it, doctor?
Let me check. It is 190. Okay, 190 from the main direction, and the number is about in the reverse flow.
In the reverse flow, I check it. This is the reverse flow, doctor.
It is 49. Yeah, 49. About 50. This is about 3.4. Let me check the numbers we have. 49.8, and for the main direction we have 190. Okay, so the periodicity number here is about. I will do the calculation. It is 190 divided by 49.8. The periodicity number here is about 3.8, okay? 3.81.
Why you must?
But for the first design, let me check it for the first design exactly to have the correct number.
Yeah.
For the first one, the pressure is here. It is 98.61. 98.61, and the reverse direction, the pressure is here. No. سلام دکتر الله حال شما حالتون خوبه؟ خبر قربان شما که ما جلسه شروع کردیم مریضاتون داریم این دایلیسیت نامبر هندسه هایی که ابراهیم زد رو چک میکنیم ببینیم کدوم بهتره، اونی که از همه بهتره رو بریم واسه در واقع بهینه سازیش. این 238
Salam to the leader.
How are you?
We are good because we have the professional leader, everything good.
صبح بخير دكتور.
How are you?
We are good, doctor.
We should, I like to, Amir Hussein, and we're saying that we should find the proper parameters to be optimized.
Inshallah, doctor, yes.
Okay.
Doctor,
If we find 4 to 5 parameters, it will be very good.
Inshallah.
Maybe we need to define about 50 cases for optimizing these parameters, and with 50 cases, maybe master thesis can be defended. But only number of cases is not the effective parameter for checking the master thesis. The quality of results also should be checked.
Doctor, we open the software, inshallah.
We have talked about the parameters and we set some parameters to be investigated, but we are looking for the best geometry to investigate the parameter in the best one, not in all the geometry, because it will increase the number of simulations that we have to perform.
Look,
Doctor, you see third one? This is the third one. Now I open one of them. This is the first.
Yeah, for the third one, the pressure, we have 274 divided in the main direction and the other direction. In the reverse direction, the pressure is 66. 66. Yeah, the third one looks the best one. You see 242.74 divided by 66. And the number is 4.15. Okay? I checked the diodicity number for all geometries. For the first geometry, the diodicity number is about 2.4. Okay?
Yes.
For the second one, the diodicity number is 3.8. And for the third one, the diodicity number is 4.15. So the third geometry is giving us the best diodicity number. So if we are going to investigate the parameters to increase the diodicity number, we have to stick with the third geometry.
Doctor, I ask you for the design. We can't change design. This shape is good. This the elet shape is good or not good. Can you see it, doctor?
Yeah, I'm not talking about the shape, but the position of the obstacles that we are using in the middle of the channel can be investigated. Okay, the position of that obstacle. The ratio between the outlet and inlet diameter can be investigated.
And doctor,
this distance, as I showed you before, the distance between the channel and the wall can be investigated. Okay.
Okay.
Let me check the parameters again.
We have, doctor, this is
So, do you have my page? Can you see my presentation?
yes, doctor, I am with you. I want to open this,
Okay.
open the software to show you something.
Okay. As I said, as Dr. Ramyar is joined to the meeting, I'm going to check the parameters again with Dr. Tu. One of the parameters, I think, can be the ratio between the diameters of these three channels that we have. For
Okay.
example, this channel can be half of the middle channel, and the middle channel can be half of the main channel. Or this one can be 1/3 of the middle one, and this one can be 1/3 of this one. This can be one of the parameters that we can investigate. And the other parameter is the location of this obstacle. We can change the location of this obstacle in this direction and see its effect. Because it is, when the flow is going in this direction, it will return the flow back. But if we change the position to the here, so the flow will go back in this direction in these two channels, and it will help to increase the dialicity. The other factor is the distance between the wall and these panels here. These distances, I think, can be optimized, because if we are able to increase this distance, then we have more chance to be able to build this geometry. Because in fabrication section, we have some limitations due to the sizes that we can fabricate. So this is another factor. We have one factor here, the other factor here, the third factor, the ratio between these channels, and the other one can be the ratio between the sizes of inlet and outlets. And the objective is delta P in the main direction and delta P in the reverse direction. So pressure drop in the reverse direction. These are the objective. This is the objective, and these are the parameters that we are going to investigate.
Angle is the left and right and up and down. Yeah, the angle of this is a obstacle angle or not? This is a panel, maybe. The angle of it with the horizon, maybe another parameter.
The angle of this channel here, this angle.
Yes.
Okay.
Doctor, you say this angle on check
Yeah.
it?
Yeah. These angles. The doctor is saying that these angles is good to be investigated. For example, alpha, beta, and gamma.
Okay.
Okay.
Okay, doctor, we check the.
So Ibrahim, now you know the parameters. Okay, have you written for yourself?
Yes, I am write everything, make تسجيل recording for this lecture
Okay.
to the return.
Great. So I'm stopping the sharing because I wanted that you understand the parameters.
Doctor, the diodicity number, if you, it is like 4, it is something very, very beautiful. Very beautiful, because I check the diodicity, it is for one stage, will be 4. It's very beautiful, because that mean our design is very, very nice on top. Because I read
what is the usual diodicity numbers in other Tesla valves?
1.8 for 1.
1.8?
Yes. That's
so we are already much forward than them, okay? We are already defeated them because it is 4.15.
okay, doctor. And doctor, for the diodicity, we have some paper. It say delta P for reverse flow over the delta P for forward flow. Same thing or different?
I have done the same thing, the calculation here.
Same thing. And we have a problem, doctor, how to write. I make it. And for software, you can check with me. I am sharing the software, doctor.
Okay.
The inlet and outlet pressure. How much put the outlet pressure? Because I am read there for some paper, we can't make it just pressure outlet. We have something reverse pressure like this.
I have a question. Does the number consider both the reverse flow and direct flow
Yes.
or not?
Doctor, the diodicity number delta P for reverse, delta P for forward, over. It is one summary of
Ratio.
the diodicity for one paper is 1.811. And I read for all paper, if you want go it to be 4 is top. The design is finished and something very beautiful.
So I will check the range of diodicity number. Maybe there are some papers with higher diodicity number, but we haven't find them.
Okay. I am research doctor.
But I will search for.
Doctor, this is one stage. If you make two stage, how much is the diodicity? We have something, because all work for one stage.
Very good.
And doctor, for software, I open software. It is not why.
Send me a paper. I think that's the connection.
Poor connection.
Yeah. Mr. Red, me a paper, what the diodicity number, a paper which you say that has the highest diodicity number.
Doctor, I send it.
I will
Send it now.
search.
Doctor, I will send it now.